blah, 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 blah. Hello and welcome to my talk called Scooby RAM, where are you? Sorry, who ate my RAM, obviously, but you already know the answer. It's Scooby who ate all the RAM. It wasn't the Cookie Monster this time. My name is Andrzej Grzesik. If you're Polish, you can say it easily. If you are not, good luck spelling and pronouncing. One short note here, if you need the slides, I will be more than happy to email them to you. Just drop me an email asking for the slides. You'll get a Dropbox link as soon as I get home. No sooner than that. Couple facts about me. I'm very proud to be a Java champion. I'm affiliated with the Polish Java user group. I co-organize GeeCON, so the event that you're in right now. I helped run something called Software Craftsmanship Kraków, founded Kraków Hadoop user group, which is now renamed. And I'm originally from Kraków in Poland, and I live in London, as many Polish people do. And I'm also very curious about what is going to happen to Brexit, because nobody has a clue. My opinions are my own, which means I represent no company whatsoever. This is a very pleasant thing to say, but it will change on Tuesday, but I won't tell you where. If you have any questions, wave your hand, shout. I'll try to repeat the question, or you can use Slido, as you know. And I like to use an inspirational quote in some places, because why not? Life's too short. So, to memory, because math Photoshop skills, I obviously have a backup career as a designer. You all know memory, you all know RAM. RAM sticks, the things that sit in your computer or in your phone. My phone happens to have 8 gigabytes of RAM or something similar, huge crazy amounts. Have you ever wondered how does memory get to and from RAM? If you have, you know the answer. If you haven't, short reminder, oversimplified, to be completely honest. But basically, the CPUs have something called caches. They read a line. They read some chunk of data into a cache line, so you read usually 64 bytes on an i7 kind of chip, one that might sit in a MacBook, and then from that you mask into, for example, a byte, or you mask some slightly differently if what you want is an int, which gives you a nice result. Byte actually in the memory is an illusion, or it's an effort of a few masks here and there. What is another interesting thing about memory is while CPUs have kept on increasing their performance in terms of clock speeds and in terms of core counts, memory was growing but wasn't growing really as fast. And that leaves something called memory gap or processor memory performance gap. People call it differently, but you get the idea. And if we look at Intel CPUs, namely those two models that you can see there, you can see that they differ by a year. They also differ by 4 physical cores, and I picked some arbitrary models. So you get 40% extra physical cores, but you only get 8/60 gigabytes extra memory bandwidth, which means instead of having 6 gigabytes per second per core, you now get 4.8, if my maths is roughly correct. Which means if you want to put or push more data through memory, that might not really work so well. And if you're following recent hardware trends, you can easily buy computers that will end up having 64 hardware threads. You will pay a bit for that, but if you buy the latest Threadripper or a latest Epic, this is scary what you can get at home for normal, decent amounts of money. To power that, obviously you will have to have a nice decent amount of RAM, but the problem is you cannot expect RAM to be instantly available all at once. That's not really how it works. And with that, we can look towards our favorite platform. Who here would consider themselves a Java developer or JVM-based developer? Most of us. Perfect. We have something awesome. We have something called garbage collector. And some people say that garbage collector is the best single advancement in computer programming since the times of C. That's obviously negotiable. Some people prefer Rust, some people now prefer Go. But to me personally, garbage collector means I don't have to worry about managing memory. If you have programmed in C, remember auto pointers, remember smart pointers, remember having 17 different string implementations. I like garbage collector. I like it a lot, and I like it when it does its job. But I noticed that some people also like to have this obsession which goes, oh, I have the GC, but if my application is slow, I need to tune it. I would like to convince you to try to approach this from a slightly different angle and think about the role of GC. The role of GC is just to remove the non-essential, not necessary objects. And you can obviously ask somebody to drive in a better way, but if they drive the way they drive, well, how about we give them better roads, or how about we give them less traffic to drive through? And this is exactly what I would like to encourage you here to do. So tuning, if you know how to tune, it's a perfect skill, it's a great skill to do, but sometimes you don't really need to resort to tuning because you can do some changes to your code and not have to tune. And how do you even know that you have a memory problem? Nah, I don't remember having any. So there is the classic one, the one that probably, who has never seen an out-of-memory error Java heap space? There are some hands in the room. Guys, your memory is either perfect or I don't believe you. One of the two. This one happens if something, you try to do something and there is not enough heap space. We'll talk about that. But before that, there is another classic, which is slightly more interesting, which is this one. It's out-of-memory error, GC overhead limit exceeded. Is it anybody's first time with this guy? There are some hands in the room. Okay, so because of that, to you, this one happens if garbage collector has spent more time than it is allowed to compared to the application. Specifically, what that means is you can see the profile, the percentage of time that the garbage collector has been running and the percentage that the application was running. The blue dots are the application, the red line, almost at 100%, is the garbage collector. What you can see here is garbage collector was trying to do something over and over and over and over. What you also can see is that application was making little progress because there are no blue dots anywhere. And with that, we can see that there were some young generation collectors and some young generation collections and some full GC cycles, mostly full GC cycles, taking a stable 3 seconds or somewhere in the 13s, 14s, 15s. And that's a hint that the application is spending most of the time in the GC. And if that happens too much, by default, it's 98% of the application time is spent in GC. You will get that. What that means is, if you're getting this one, you will get it much later than you would like to. And that's a problem. That's a problem with a metric called throughput. So throughput, time of the application spent running application code. So if your application has a throughput of 95%, from the GC point of view, it means 95% it was doing the application code, rest was done by GC. What's a good throughput? It depends on what you do. But generally, the more application compared to GC is preferable because, well, you are writing the application to do something and you want it to do this instead of doing something else. How can you know what throughput your application has? Well, you can always guess, you can always hope, that's always a very valid solution. But more realistically, you should enable GC logging. You should enable GC logging in production if possible. You should enable GC logging in development as well, so that you get used to running with GC logging and you get used to analyzing that, because it can give you a lot of good things and a lot of insight into what's happening. Who here runs GC logging? It's not even a quarter of the room. There is Jean-Philippe in the second row who is super passionate about running GC logs in many places. Talk to him during the party. He will try to convince you. Talk to me, I will try to convince you as well. How do you do it? That's an oversimplified thing. You can do something like that, which means ask the GC to be verbose, log it into my own very file, and you can use something called GC file rotation, and you can tell it how many files you should rotate over. And you can say what the maximum size of that file should be. But I would tell you, approach it slightly differently. If you restart your processes, at least start with this -t. That will give it a nice timestamp, so you will know when the when the process started. This file will get created, because if you create not enough chunks and you do too much GC logging, you might overwrite something, and then figuring out which chunk is which, that's just tricky. You can of course combine this with the chunk with the rolling logging, and that works reasonably well. So for JDK8, that's an example. Is it the one that you should use? You can start from that. I won't tell you that this is the perfect thing, because your mileage will vary. Do what you need, not what I show you always. And you can also notice that this says JDK8. I mostly work with JDK8. I haven't been able to migrate to the more recent JDK versions, mostly because of Hadoop, and mostly because the versions of Hadoop I work with are certified and supported with JDK8, so sorry. But if you're in the newer space, if you're in the modern land, you are JDK9 or onwards, there has been a change called Unified JVM Logging, or JEP 158. And I've heard that if you want to sound cool at a conference, you should quote any JEP by the number and people will think you're an expert. As you can see, the syntax to enable GC logs has changed slightly. Obviously, this is an example. You'll find a lot of references for different options available online, but I wanted to highlight that this is a thing, and then you know what to do. One important thing, please watch out for putting GC logs on slow devices. I've seen some people who have, for example, triggered very long GC pauses because the disks that they were trying to write to were full and everything was just hanging. This is a caveat. And I've shown you some options. Java options are things that you do with -xmx or through -xx, something, something, something. And since I mentioned garbage collector, you should use this flag, the +print flags final. What it does, it lists all the flags that the JVM has set, and it lists all of their values. It also lists their types, so you can see is it a boolean or is it an int, and you can see which part of the JVM they apply to. Somebody could say, why should I do it? Well, some flags might trigger changes in others. That might be unexpected. There might be some conflicts, there might be some overrides that you might trigger. The only way to know what settings the JVM was actually running is to ask it to tell you what settings it is running. Quite obvious, but you have to know that the thing is there, and now you do. And out of those flags, you might discover something which is called heap dump on out of memory error. What it does is exactly what it says. It will make a heap dump when you have an out of memory error. Why would you do it? Because then you have a file that you can analyze and you can see who was the biggest culprit, what objects were in the heap dump. Did you expect them or are they unexpected? If you expected them and there is more of them than you expected, maybe it's a hint that you should increase your heap size, or maybe you have to do some work. And there is a heap dump path, so you can give it a path, quite normal thing. And since we're talking about flags, flags can change between releases. They will change between releases. It happens organically as work on the JVM happens. As I said, some flags, they might change their defaults, they might change their values. You should do print flags final. Get into that habit, because trust but verify. What are the points of reference for flags? Well, obviously you can read the JDK sources, but this is a bit of tedious work. At least I don't have the time to do it. I'd love to, but I don't. Or there is this awesome website called Chris Who Codes, which lists flags, and it looks like that. It is a huge table, and it tells you which JDK, what is the meaning of the flag, is there a default, what's the type, which operating system is affected. And this is a great source of knowledge, because at the top you have a search field, because this is written with some modern JavaScript, so you can do a search and you can see what happened. And for example, this aggressive ops, you can see that this has been deprecated in JDK 11, obsoleted in JDK 12, expired in JDK 13. And as a bonus, I can share something from my own recent history. XX plus use NUMA isn't properly set. In theory, this is something that the JDK should set if your system that you're using has multiple physical CPUs. But for me, sometimes it wasn't, so I have to set it manually. How did I learn about that? By using print flags final, because by default, reading the docs, I would expect it to be set correctly. So let's put out on out-of-memory error in that search field, and we get to learn that there is one nice thing. It's -XX plus on out-of-memory error, which can lead to a path to a script. And if it's a path to a script, you know that you can react to having an out-of-memory error. What do you want to do in that script? That's completely up to you. But if you get to talk and have some effect on your runtime, in production especially, that's an awesome thing to know. Or you can tell that to your admins and then hope that you can start a dialogue and have a proper DevOps environment. And with that, let's say we've covered chapter 1. Let's focus on, yeah, that was an awesome talk. Have you been there? If you haven't, perfect. If not, wait for the recording. It was really a very good talk. But I can say there are two categories or few most popular culprits whenever it comes to observing memory problems in production JVMs. Number one definitely goes to java.lang.String. The first question is why, because up to, including Java 8, a java.lang.String would contain a char array. A char array under java.lang.String means you'll get the extra object header, and then you'll get the object header for a char array, and then you get 16 bits for every single character that exists if it fits under UTF-16. You know that. Luckily, as Heinz and Dimitri expertly explained in their talk, from Java 9 you get a byte array instead, which means you get to save half the memory. What can you do in Java 8? Well, there are two options. We'll cover the second one slightly later. The first one that I sometimes use, because it's a very cheap trick, but it sometimes does the job, is just getting the bytes printed out as UTF-8 and storing the byte array. What I get for that is I don't get strings, I don't get hash codes, so I will have to create sometimes strings in order to change the API, but that sometimes allows me to go forward. And you might say, well, this is quite strange, but there is a context to which I'm getting, and this is the context. This is why I'm angry at strings. Strings, I'm not angry at you per se, I'm very angry at JSON. JSON is a great format, it's human readable, it's permanently in debug mode, it's very easy to change values in strings. You just create yet another giant string which contains the new JSON. Seriously, if you have to use JSON, but otherwise try to think about binary formats. They will be nicer to everyone, to the environment, because you will have to spend less electricity processing your code, have less carbon footprint and so on. And just be nice to each other, use proper binary protocols that can have a schema, can have values, and are somewhat optimized. JSON is great, but not everywhere. I've seen a few gigabytes of JSON files, and this has really changed my life, not in the direction that I expected. And now a short water break. As I said, you can also hope for the JVM to do some magic with strings. The second option that you can do is use string deduplication. Using string deduplication in JDK 8 is available only if you use G1GC. And if you run G1GC in JDK 8, that means that your full GC phase will be single-threaded, which can take minutes, or even more minutes. Why would you do it? When would you do it? This is a screenshot from GC logs having been analyzed in jClarity, and we'll get to that tool in a second. But notice the difference. The left screenshot shows data about a piece of work completed. The right, not so much. It finished faster, but it failed. because it ran out of memory, because all the strings contained way too much memory. So you can sometimes, by changing the flags, changing the garbage collector algorithm, and adding string deduplication, allow a process to successfully finish slightly slower, and your mileage will vary because it really depends on what you run on a particular system and in a particular JVM. But you get to somehow make something finish. If it's Friday late at night, being able to at least move things forward is beneficial, because you will be fixing the code on Monday, because Monday is better for that. I wanted you to know about that. It's probably not something that I would do in most production environments. I don't recommend using that all the time. However, knowing that it exists might be useful. So what's changed? String deduplication made everything slower, because figuring out which strings you can deduplicate takes time. You have to compare them. But it reduced overall memory consumption because you've reduced duplication. And in this particular case, this allowed the left application to complete successfully, which is quite awesome. And I'm showing an application called jClarity Sensum, which is an application that allows you to analyze GC logs. So it's a natural question. What can a GC log tell us? Well, this is an example. I'll give you, 15 minutes, and then I can ask questions about what can you see here. No, not really. This is the log from Java 8. It's an example. You should be scared by the wall of text. This is the only impact that you should see. And this is an example from JDK 11. As you can see, the format changed. Because of that, if you try to run a lot of regular expressions against it, you will spend a lot of time. And those formats sometimes might change. I would recommend don't do it. I would say use a tool, benefits from the work some other people have done, stand on the shoulders of giants. I will mention two things here, gceasy.io, which is a website to which you can upload your GC log and have it analyzed. Great if your organization allows and is happy with you uploading GC logs from your production environments to a random website which will do whatever. And something that I personally like called jClarity Sensum. There are other tools that allow garbage collector logs to be analyzed. Google is your friend here. If you're using some certain JVMs, they might come with their own log analyzers. But we will focus on Sensum. It's a paid tool, but it's a very good one. The company has recently been acquired by Microsoft, but at the moment the tool still works, so I don't expect Microsoft to break that tool actively. However, I don't know what their future plans will be, just so that we're clear. Those are the options, or those are this is the analytics that Sensum provides. This is the left pane. We'll see the demo if timing permits. What's usually important, where I usually start, is summary data. You can see that a particular log took 93,000 seconds. If you like to do the maths, do the maths. You can see total bytes allocated, which is 26 terabytes. How do you interpret this value? Well, this means that if you were to run with no garbage collector and you were to remove no data from memory, you would need to have 26 terabytes in order for this workload to complete successfully. 26 terabytes of RAM, anyone? Yeah, so garbage collector, it's awesome to see you here. You can also get to a graph which looks like that, which shows you the speed over time of how the data was being allocated. What you would usually look in here for are some spikes to see if anything strange is happening. But you will also look at average allocation rate. That's obviously the lower you get there, the better. Max allocation rate, obviously lower the better. Average recovered rate, so I think you understand that. Total pause time, 900 seconds out of 93,000 seconds. So you can see that the throughput was 99%. So a reasonably solid case. It looks like this particular workload was running happily. And I mentioned 26 terabytes and not having any RAM. So it's only fair I mention something that exists in recent JVMs or JDKs, which is a no GC. So the GC that does exactly nothing. Why does that exist? It makes no sense, somebody could say. Yeah, that's a correct thing. The reason, or the thing I'm talking about is epsilon, a no-op garbage collector. You run it through those flags. And why do you run it? Because if you are trying to reduce allocations, if you're trying to prove that, for example, your application is happy with a heap and it's stable and it will not generate too much garbage, or you want a proper experimenting tool, this is the one to use, or this is probably one of the things that you should use. Because this will do nothing, by definition. You know that A, you're not wasting any runtime for the garbage collector because it's doing nothing. And you know that all the garbage that you produce ends up in the heap dump that you will get at the end of this. So you can analyze whatever happened and then do your police work. And I said a heap dump, so another chapter is upon us. What can a heap dump tell us? A heap dump is a record of the memory that the JVM was working with. It's going to be a large file. If you are having -xmx16g, you might end up with a 20 gigabyte of a file. What can you use to analyze it? Those are just some of the tools. Sadly, at the time of writing, Java mission control doesn't by default allow you to load a heap dump and analyze it. Why? I have no idea. There are plugins that you can use to do that. However, to get plugins into some of the mission controls releases, well, you get to recompile, which means it's extra work and it's super fun. If you don't know which tool to use, you can start with Visual VM. JProfiler and YorkIt are paid tools. You should also give Eclipse Memory Analyzer a try. My way of working with all those tools, I mix and match. Some things are easier shown in some, and you have to see which tools your brain works with best. I know that my brain is limited in some capacity. I just cannot be very efficient with Eclipse-based tools. That doesn't mean that there is anything wrong with the Eclipse Memory Analyzer. It's an extremely good, extremely feature-rich tool. It's just I don't get to talk to it properly. I don't know how to do it. And some caveats if you want to do heap analysis. A heap dump file from a 16 gigabyte heap will be larger than 16 gigabyte, which means you need to have a bit of RAM, you need to have a reasonably fast hard drive, you probably will need to bump the the XMX for the process that is analyzing the big file, because otherwise where is all of the information going to end up? And sometimes some tools will fail analyzing certain heap dumps. It's just a fact of life. It just happens this way. Some might take a few hours to load a heap, some particular heap, and then be super successful and super efficient in the other. You have to do your own experimentations. This will change as you experience. And then I mentioned Eclipse Memory Analyzer. And this is a screenshot that you get. I'll be nice to you, I'll zoom in. They already have a few predefined views for the most popular searches, for the most popular things that you would look at if you want to analyze a heap dump. So you'll get the dominator tree, so you'll list the biggest objects. You'll see a histogram, so you can list the number of instances of each class to see if it matches your expectations. You can see which classes are duplicated, which means multiple class loaders, all of the usual things that you would do when analyzing a heap dump. The great thing about Eclipse is you can save some of the other reports, as in save the definition of a report and then reapply them to different heap dumps. This is a very neat feature, especially if you will spend more time working with heap dump analysis. But then other tools have similar things, similar reports available elsewhere. This is a screenshot from YorkIt, I believe. Yeah, it says YorkIt at the top, so it is YorkIt. And you can say that it can give you duplicate string report, for example, in a different spot. And this one is a particularly bad choice because the most duplicated thing is meta-inf manifest mf, which is wasting 15,520 bytes. Oh my god. But what's the conclusion here? At least try one of them. If you don't like the first one you tried, try the other one, see which one is you're compatible with. Learn your way, click through them, and analyze the heaps. And I wanted to mention something that's reasonably new, that's being developed in the open under Adopt OpenJDK, something called jheapo. This is a tool that allows you to convert a heap dump into a graph. If you've worked with a graph database, you will know your way. But what you can see, or what you could see, is a graph of classes, and you can approach it through different from different angles. You can obviously ask it to give you the most popular objects, or what are the 10 most frequent classes loaded, or which class loader has the biggest, you name it. But because what you create as a graph structure, you get to query it as a graph structure. So you can, similarly to working with memory analyzer from Eclipse, create some queries that you will then apply to a graph database that you can, for example, automatically generate upon heap dumps. And then you can create a pipeline of analyzing problems. And if you work in a large enterprise environment, that might save you some time. And with that, we'll move on to culprit number 2 in my personal list. And my question would be, do you do things like that? And I have nothing against using array lists. It's a perfect data structure, and I have nothing against long, even with the capital L. However, here is a Sensum view of allocations of a piece of code that was using array list of capital long. Is it good? Is it bad? I'm not going to ask anybody to interpret that, but there was a change implemented. This collection has been changed to a long array list, so a specialized collection that operates on lowercase longs. You can see that the allocations have dropped. By how much? Depends on your particular use case, what you do with the longs, what you do with the array lists. What the conclusion was to the runtime was, I would say, pretty significant. This is obviously an application I had access to, and your mileage will vary. You will get different results because it really depends on what you do. But please, 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 for everything that's nice in the world, use specialized collections if you work with a lot of numeric primitive types. You can use Eclipse collections, you can use fastUtil, you can use plain old arrays. Whatever it is that you are most happy with, do it, but don't use array lists of things. And having said that, please also run your own benchmarks. Don't trust my word that your code is going to be faster by X% because I've shown a graph. No, it really depends on what you do with certain areas in the code. It might be that it will not impact your application whatsoever. It might be that it will make a life and death. And after you've analyzed all of these things to the nth degree, there is something that's a very popular research subject, something called escape analysis. Trying to, again, give you an oversimplified definition, is the JVM is trying to be nice and smart and identify objects which don't really get to exist on the heap because they are created, interacted with, and they don't matter anymore. So they can be eliminated. And this is a very popular research area. So I've tried to type it into the ACM digital library, escape analysis in Java. I got 26,912 results. And this is correct as of today. And how do you get a log that can show you that? You can do Java minus this and that and that. Doesn't matter. Which tool do you use? The tool is called JITwatch. What do you do with a tool called JITwatch? You download, you compile, and you launch a UI. A UI, and this is showing just a sample, will show you which objects created with new create this strike-through new line, which means they have been prevented from being promoted to the heap, which is always a win because that means we don't push an object all the way through RAM, and then the garbage collector that has to analyze all of your object graph doesn't have to go through that object each and every time to say, nah, it's not as necessary anymore. So we're trying to make the garbage collector do less work so it can finish faster. Should you do it? I would say as one of the later stages of optimizing anything that you do. And with that, what is the first one? Okay, very good question. Use, for example, Visual VM or NetBeans Profiler because the component called JFluid is exactly the same in both. Is it the only one tool that can do it? No, you can get same results from any profiler that probably exists and is sane. You want to do something called allocation profiling. This means asking the application to tell you where does it create objects, where does it produce garbage. How do you do it in this one? This is Visual VM. You click on the memory tab, you then click on memory. You have to select proper filters, so you are interested in your own code, and if you're using Hibernate and you want to know that Hibernate is actually the biggest culprit in your applications, well, please include it in the filters. If you know that you're not going to get rid of Spring and you want to not see Spring in there, put it in the filters. And then you wait, because the application with allocation profiling will be much slower, so you cannot run it in production, or you should probably not run it in production unless you really don't care. And what you will get is different places will come up into that list, and you will see how many live objects, how many bytes, how much of everything has been allocated. And then you wait and wait and wait, and with that, you're happier because you are software developers. You can change the code. You can try to see if the changes that you have done have brought you any effect. And with that, caveats, of course. You will need to run benchmarks. So if you make a change, you will have to see if that change has had any effect. Please run the changes with GC logs, because as you have seen, GC logs can tell you a lot of the things about allocations. Use an isolated environment, because if there is a lot of noisy neighbors in where you run your tests, and they make your application run really, really slow, this is going to give you strange results. It would be ideal if you can get a similar machine to what you run in production. However, if your heaps are in the 500 gigabytes range, it might be expensive to get there. And be distrustful, so design experiments proving sensitivity, so how the application reacts are what you expect. And yeah, let's have a short pause. And we still have time, so it's enough to have a look at something. So, can we do this? Yes, it worked. So I've shown you Sensum. This is the application I mentioned. I would say it's pretty nice. When you launch it, do I get to see that? When you launch it, it screams at you, get your free 1-year license. So there is some way to get a free license for it. I wouldn't call it too expensive, especially if you're trying to save your company a lot of money. But I wanted to show you what it can do. At first, some quick and easy checks. Don't pay too much attention to what numbers you will see there, but you'll see if there is anything completely wrong with your application, something that you should change. There have been no calls to system.gc, so nobody has been trying to trigger the garbage collector manually. There have been high kernel times, but we're going to ignore it for now. This is the summary view that you've seen in the presentation before. So a quick and easy way to see is it completely wrong? Is it mostly okay? You can see heap after GC, so has the GC reclaimed something? Well, you can see that there is an obvious trend in here, and there is an increase of memory. It's quite visual, so you get to see that. which means there is either a memory leak or a resident set in the application that keeps increasing. Heap before GC, as it says, different generations. You can see churn, which is the aggregate allocations that I've mentioned that are my favorite subject. If you can reduce allocation rates, you're always happier. This application displays allocation rates all over the place. In short, if you can reduce this from high up and put it down, you're happier. Also, you don't have to use that tool. I mentioned the free GC thing, the GC Easy Analyzer, and this is what it looks like. And you can see that one of my Facebook friends actually likes it. So, good for them. It's a decent tool. Basic information about the GC log, extracted from the GC logs, average pause time, max pause time. If you want to know about low latency garbage collectors, watch the video from Jean-Philippe's talk from today, or from May's GeeCON, obviously. Pay no attention to the details. They don't matter, but you get to see all of the information that Sensum is showing me as well. Heap after GC, here you can see there is no change, which means the garbage collector doesn't get to do anything. So it's probably going to get this overhead limit exceeded. And it did, because that's exactly the GC log from that case. So GC pauses of 25 seconds, and in that neighborhood, pretty bad. Reclaimed bytes, pretty low. So somebody who has seen Chernobyl could say not terrible, not great. I would say completely bad. Old gen, different phases, different things. Let's go back here. So, and you can also see what caused the GC cycle to kick in. How many of have there been any full GCs caused because of anything? Not really. Mostly. There are questions. Perfect. Since we have time for questions, is there a way to push heap dump somewhere else besides the file system, stream it somewhere? I haven't seen an option like that. If you mount your streaming endpoint somehow that looks like a file system to the JVM, maybe you could do something, but I personally have not seen anything like that. So I am personally unaware. I see hands saying no in the room, so probably not. What about using async profiler for allocation profiling? I would say that that should work. I have not used it myself in that way. However, I see Jean-Philippe says double thumbs up. So yeah, please try, give it a try. It should work. It's a profiler. It should do what other profilers do. Something's better, something's even better. It's a great tool. Should we ever tune GC in production environment? If yes, when and why? I don't have a problem with people tuning GC in general. I have a problem with people running to tuning GC if they have problems everywhere else in the application and believing only GC tuning is going to save them. If you've done the work, if you've changed your application code, it might be that you as a software developer have a faster, cheaper, easier, more easily applicable effect on the application and how it runs than trying to get somebody who knows how to tune GCs. If you know how to tune GCs, on the other hand, and if you know that by adding a few flags and you know what values to use for those flags, you will get an effect faster than doing a few weeks of coding, it's completely up to you. I'm a lazy person. I understand that the GC would like to be a lazy entity as well, so if I don't give it garbage, it will not have to process the garbage. However, if you're comfortable with tuning GC, sure. If you want to hire or get a GC tuning expert into your company on a short notice, those experiences tend to be very educational, however, very expensive. It depends on how much imperative you have for that activity. It's a valid option, absolutely. And tomorrow at 3 p.m., how to quickly analyze heap dump automatically in Java, OQL, JavaScript, Python, Ruby, hidden under name Design APIs for Polyglot World. Well, very good shout out to the person who has written that. Do we have any other questions? One. Yeah, there is a question in the back. So direct memory, anything to that? Yes, absolutely. There is a lot of analysis to do with memory that this talk doesn't cover because it's only 50 minutes. I wanted to show you tools so that you can start with something. If you're already an expert, then yeah, there are areas in here. If you have, for example, memory mapped files that you misuse, I don't think these will show you those. You will have to approach the problem differently. But I approached it from what are the most popular cases or the quickest wins, because those are the things I've seen most recently, most often. So quickest wins from my history. What you say is absolutely correct. They will not show you absolutely everything. You will have to approach the problem differently. If you want to talk more, let's do it after the talk. Anybody else? I think that means it's a no. So may your memory be free, I guess. With that, I have to say thank you. If you want the slides, drop me an email. Thank you so much for staying with me.